Welcome back, everybody. Welcome back to ALEKS. We've got a couple more topics to cover this week. This is the first of 3 videos today. The first one is on degree of a multivariate polynomial. So to go back to some vocabulary here, we were talking about univariate polynomials last week. Multivariate just means that there's more than one variable in an expression. So this is a little bit different. If you remember when we just had one variable, what we could do is we could say that we're looking for the highest exponent. And we can go through all of our terms and see that the first term has the highest exponent. So that was going to be the degree of this polynomial. Well, with a multivariate one, what we have to do is look at each term individually. And we had to figure out with each term, which term has the highest degree. So if we take a look at this one here, the first term of this polynomial is right here. This is the second term of the polynomial. This is the third term, and this is the fourth term. So we're not going to just add all these numbers together. What we're actually going to do is do each term separately. So what I want to do first is this one right here, -2, that has a degree of 0. So we don't care so much about that term. 5x has a degree of 1. So we don't care so much about that term either. This term right here, we've got 7 and we've got 5. If you add that together, it would be 12. And then over here, we got a 3, a 2, and a 6. We add that together, and that is 11. So once you find the degree of all 3 or all 4 of your terms, you're just looking for the highest number. So the degree of this polynomial is 12. And this is only what you do, remember, when it's multivariate, when you have more than one variable, which means you have more than one letter. Here it was just x's. But over here we had y's, we had x's, we had v's. So because there's more than one letter, we have to count up the exponents in each term and see which one's the highest. So let's take a look at this one. This one's kind of similar. This is the first term right here. This has a degree of 3 plus 6 plus 1. Keep in mind that if it's just u or just x or just a variable, that there actually is an exponent of 1 there. So what we're going to do here is we're going to add 3 plus 6 plus 1, and that's going to give us 10. As we saw in the last one, constant doesn't even have a degree. It's got a degree of 0. Here, we have this term in the middle. We've got -5v to the 6th. That just has a degree of 6. And this last term here, u to the 7th plus, u to the 7th and y squared, we add that up and we get 9. So the degree of this polynomial is the highest number, which in this case is 10. The last one here, again, kind of similar. But what I want you to pay attention to here is the fact that this is a little bit out of order from what we just saw. And also, there is another w here that just has a 1 as the exponent. So those are a couple things you want to pay attention to. The order doesn't really matter. Usually these problems are a mess. But what is important is which term has got the highest exponent. So this first one, you've got 4x to the 7th. The degree of that is just 7. Here we've got a degree of 3, 4, and 2. We add those together and we get a degree of 9. And then this one here, as we know, it's a constant, which has a degree of 0. And this last one here also has a degree of 7. If you notice here that these two terms both have a 7. Now, if this wasn't 9, if this wasn't the higher number, and we had two terms that were 7, then it would just be 7. We would make our degree 7 because both of those have the same degree. Now, because 9 is bigger, this is what we use. So the answer to the question here is 9, but if that second term wasn't there, we would have a degree of 7. So if they tie, it's like they're both the degree. They both represent the degree.